Hi everyone. Sorry that I am not with you today. I will be back Monday. For those that didn't see on the weekly agenda or our slide, I am going to be moving our test back. So we'll talk about that on Monday. Just know it's going to be pushed back about a week. Yeah, celebrate. Okay, so task 6 is the greatest integer function. Some of you have seen it, some of you have not. Notice this is our parent function right here. Notice the brackets. It is not the same as the absolute value function, but it's very easy for us to get the two mixed up. Please always take the time to figure out, is this a bracket or is this an absolute value bar? Now, the greatest integer function has a function. Its function, how many times can I say that, is to bring whatever the input is to its closest or its greatest integer that it has passed. So as we go from left to right, so we start at negative infinity and we're moving left to right and we stop at 1.5. The greatest integer that it has passed on the number line is 1. So the greatest integer of 1.5 is 1. The greatest integer of 2.1 is 2. The greatest integer of 4, well, that is an integer, so it's 4. The greatest integer of, let's say, negative 1.9. Ooh, you might be thinking negative 2. Be careful with these, with the negatives. That's what I mean by these. Because if I start at negative infinity, and I go from left to right, remember we read a number line, a graph, just like we would a book, and I stop at negative 1.9. What's the greatest integer that it's passed? Negative 2. So the greatest integer is often called the fallback function because you're falling back to the closest integer. Now, its parent function is what we're going to graph first. And I'm not actually going to give you a table of values, so when we graph these with transformations, it's going to be a little bit different. What I'm going to do is, I'm going to get orange, there we go. I'm just going to tell you how to graph it. Our h and k for the parent function is what? Well, 0, 0, right? So that is going to be my first starting point, my first closed point. And then I'm going to extend to the right because every number between 0 and 1 has a greatest integer of 0. But what's the greatest integer of 1? It's 1. So at 1, 0, I have an open circle because I jump up to the next integer. And then I extend out, What's the greatest integer of 2? It's 2. So again, open circle because every number that's in there in between 1 and 2, every number that's in between 1 and 2 has a greatest integer of 1. So we get these steps. Sorry, I'm adjusting my eraser. We get these steps that extend out to the next integer, and then they jump up. And we can work backwards also to create this staircase. The greatest integer function is referred to as a step function because it is just that. See it? There's steps. You're welcome. Okay, so there's our greatest integer function. Please note the domain is all real numbers, and the range, well, there's steps. So I don't include any of the numerical values in between the integers. We just say it's all integers. For those of you that like fancy symbols, you can write the integer symbol. It's a fancy Z. So on your notes to your forgetful self, if you need to, go ahead and pause this video. Write down or copy the parent function for the greatest integer. Okay, and remember, we always started at that closed circle for the parent function, and you might want to write this down. We started, get it together, Patterson. We started at 0, 0, the origin. Then we extended out 1 and up 1 and so forth. Well, question for you, because now we have to be able to do this with transformations, but Patterson didn't give me a parent table, so how am I supposed to do this? Think about what your transformations are, what we have. We have A, which is our vertical stretch, compression, reflection. We have B, which is our horizontal stretch, compression, reflection. You have H, which is that horizontal shift. And you have K, which is the vertical shift. And as I've mentioned so many times before, the location of each of these transformations doesn't change. Your A is still out in front of the function. B is still inside of the grouping symbol, in this case, the bracket with X. H is also inside of the bracket, but it's factored away from B. And K is on the back end. This doesn't change. Okay, so how does it affect our graph? Well, if A is a vertical stretch, okay, these are steps. If A is a vertical stretch, what is it going to affect? Aha, hopefully you said the distance between the steps. Distance between the steps. Nice. And, I wrote these too close, sorry everyone. And if there is a reflection, it might affect the direction of the steps. So let's go ahead and put direction of the steps. And for those of us that need the visual, if there is, if there is a negative in front of that A, instead of going up, our steps are going to switch and they're going to go down. Why? Because we have that vertical reflection. If you need a visual, I'll be more than happy to show you when I come back on Monday, okay? Because it's a lot easier to see in person. For now, just know that it will change the direction of the steps to going down. We'll be walking down the staircase. Now B, we're still going to take the reciprocal of it. So if my B is 1/3, then, in the equation, if it's 1/3, then that means we're affecting it by 3. And think about this too. Because a lot of us, side note, a lot of us struggle with the B value, right? Let's say that we have this absolute value of 2x, but we acknowledge B to be 1/2. Why? Because Patterson told me. Trusting, but we should understand the why. If I drive to school, okay, and normally let's just say it takes me 10 minutes to drive to school. If I drive now, let's say twice as fast because I'm running late for whatever reason, I'm like, oh no, my second period is going to be so mad I'm not there on time. If I drive twice as fast, I will get there in half the time. So the B value speeds up how far we're getting to the next value, thus it's going to take us half the time. If, conversely, let's say that I'm driving half the speed I normally do. So normally I drive, let's say 40 miles per hour, but now I'm going to drive 20 miles per hour because I'm tired. Well, that's going to take me twice as long to get there. Okay, so that's the idea behind the B value. Hopefully that made sense and helps a little bit if you're struggling. So if B is our horizontal stretch, compression, reflection, what is that going to affect? Horizontal step function. Haha! It's going to be the length of the steps. And it's going to affect the direction of the open circle and the direction of the steps. Okay, so it's affecting both the where the open circle is and the direction of the steps. Alrighty, Roo. H is still our horizontal shift, so this is going to affect our starting X value for our first closed circle or closed point. And then K, being that vertical shift, is going to affect the starting Y value of our first closed point. Again, if you need to, because this is on the Notes to Your Forgetful Self, if you need to go ahead and pause the video so you can finish writing, please do so. If not, let's keep going. So I'm going to do 2 examples with you, and then I forget on the notes if it says copy down or do a new one. Regardless, follow the directions. I literally should know because I copied them for you, but regardless. Okay, so look at example number 1. If you want to copy this down on the back of your Notes to Your Forgetful Self so you have extra, in fact, let me just look so that you have extra practice, please do so. Yes. I do have a new example on the notes, so copy these on the back. First thing I see, we have A, B, H, and K. So what do we have to do? Heck yes, we're going to factor out that B value. Remember that factoring is simply dividing. So if I take a -2 divided by 1/2, I'm going to end up with 4. And there we go. I'm going to, for the sake of our example number 1, write out what A, B, H, and K are. And then our H, remember to always take that opposite sign, and K, we take the same sign. So here we go. Now, it says to write down steps of how to graph with transformations in the upper left corner of your Notes to Your Forgetful Self. Let's walk through it together. The first thing I need us to do is identify our HK, and we already did that. The HK tells you where your first closed point is going to go. So I'm going to go to 4, 1, 1, 2, 3, 4, up 1, and that's going to be my first closed point. The second thing that we need to figure out is whether we are going to extend our steps to the right or extend our steps to the left. The only time that we would extend to the left is if there is a horizontal reflection. If you need to, write that down. The only time that we would extend our step to the left is if there's a horizontal reflection. Here, our B value is not negative, so we're going to extend our steps to the right. And the third thing we need to do is figure out how far we're going to extend. So since our B value is 2, the step length is going to be 2 units. Let's go ahead and do that, yeah? Let's extend out 2 units and make an open circle. The fourth thing we need to do is figure out if we're going to go up or down. Now, with our parent function, we had a climbing staircase. For us to have a descending staircase, I don't know why all these things are popping up. Stop it. For us to have a descending staircase, we need a vertical or a horizontal reflection. Okay, again, if you need to, write that down. We don't have either. A is positive and B is positive, so our steps are going up. The fifth thing that we need to do is figure out how high up our steps are going. That's going to be our vertical stretch or compression, so we are going to have a distance between the steps of 3 units. I'm going to go from my open circle up, 1, 2, 3. I'm going to extend out 2, open circle up, 1, 2, 3, close circle, extend out 2, open circle. And I'm going to work backwards because you really want to have as much of the graph as possible covered so that whoever's looking at your graph, be it you, a classmate, me, somebody else, can really see that you understand, oh, okay, they're increasing the steps. They're 2 units in length, 3 units apart distance-wise, 1, 2, 3. So then I'm just going to work backwards a little bit. 1, 2, 3. Ta-da! And there it is. Isn't that delightful? So again, if you need to, pause the video, gosh, sorry, and write down these steps. Let's do one more. Oh, get it? Steps, step function. I'm even funny in my video notes. All right, here's our second example. Don't deny it. I'm comical. And the first thing I see is that I'm going to need to factor out the negative. Don't forget, sometimes we do have to factor out a negative. That's going to leave us with x plus 1 inside the quantity. Let's identify where we start. Step number 1. H, always the opposite sign. So I'm going to start at -1, -3. Let's go ahead and plot that. So I'm going to go to -1, 1, 2, -3. The second thing we need to figure out is whether we extend to the right or to the left. Is there a horizontal reflection? Yes. If you're not sure why, take a hot second. Come over here and write down what A, B, H, and K are. There is no shame in having to write down what these transformations are. I know I make you do it in formal language, but especially for the greatest integer function, if you need to write them out, do it. All right, so since B is negative, we are going to extend left. And how many units? Well, B is just -1, so we're only going to extend 1 unit left. What does that look like? Like this. I'm going to extend 1 unit left to my open circle. Okay, if we have a horizontal reflection, we extend 1 unit left to the open circle. All right, so then are we a climbing staircase or a descending staircase? Since we have a negative B value, we're going down. How many units? Look to your A value. We're going to go down 2 units. Always from the closed circle. If you need, well, that's a lie. Always from the right side of the step. That is a truth. So from that right side of the step, I'm going to go down 1, 2, open circle to closed. Oopsies. And it's only a 1 unit step. Down 2, open circle to close. And let's go ahead and work backwards for a few steps. I'm not going to discuss domain and range for any step functions that have shifted by any transformation. So just know it for the parent function. That's what I'll be focusing on. Sweet. All right, my friends, hopefully that was, I know that was a little bit quick, but hopefully that was a good breakdown of a procedural graphing for this lovely function. Do your best to work together, and I will see y'all on Monday. Thanks.